Hello and welcome to Algebra. Today we're going to look at 7.4. We're going to look at division properties of exponents. Alright, so in this case we're going to have a group that Chuck Norris is going to have to deal with. Of course it may not be Chuck Norris, but it's going to be a group. Anytime you have this quotient, you have say x squared over y to the third. If you can raise that to say to the fourth power, you just distribute. So distribute it right across. So there are four groups. Again, you're going to Xerox it. If you make 4 copies of 2, that's 8 copies. If you make 4 copies of 3y's, that's 12y's. So you're just multiplying basically. Alright, now let's take all of what we've learned. We've done the Chuck Norris, we've had groups of, rack 'em up, all this. Let's put this together in what we know and add one new twist to it. So the first thing I'm going to do, I look at this and the first thing I notice are these. So I'm going to have to deal with those first. That's what I would do. Now a to the first, we're going to have to move that down. B to the negative first, we're going to move that up. And C to the negative third, we're going to move that down. So we have 12. The B to the sixth stays. The C, let's see, the 4 down here stays. A to the fifth stays. The C to the fifth stays. So that's all that stays. Notice all that's in the blue here, that's going to move. The 12 moves, the 12 stays, 4 stays, anyway, all that stays. Now, A to the negative first gets booted down, so it's A to the first down on the bottom. B to the negative first moves up, and it's positive now. C to the negative third moves down, and it's positive now. So the next thing I'm going to do is to combine these, the B's, the A's, and the C's. So we have 12. Just rack them up. You have 6 B's, 1 more B, that is 7 B's. You have 5 A's, that is 1 A. 5 plus 1 is going to be 6 A's. C to the fifth, C to the third, 5 plus 3 is 8 C's. And you do want to put these in alphabetical order. That is just the standard protocol. That's what real mathematicians do. And the last thing we want to do is when we look at this 12 fourths, 12 fourths, if we saw that in a different context just by itself, we would say that's 6 over 2 or 3 over 1. So we want to make sure that we reduce that all the way down. So 12 fourths would be 3 over 1. But in reality, we don't really need that 1. So 3b to the 7th divided by a to the 6th, c to the 8th. And that'd be your final. How do I know that's my final answer? Well, there's no negatives. Exponents, there's no exponents of 0. You don't have any fractions that need to be reduced like this. So that is done. That is simplified. Let's try one more. But this looks absolutely crazy. And you notice there's going to be Chuck Norris in a group. Well, what happens when you have Chuck Norris in a group? Well, let's find out. So basically what happens when Chuck Norris has a group, Chuck Norris takes out the whole group, which we could have probably guessed. Let's take a look at the problem. This negative, when you deal with negatives in a fraction, and especially in this context, you kind of get to make a judgment call. Do you want it to go into the numerator or the denominator? One or the other, not both, because if you had negatives in the top and the bottom, negative divided by negative is a positive, and you don't want that. It is a negative. I'm just going to move this up to the top. So I'm going to move things around just a little bit. And of course that fraction is going to freak people out. Don't worry about it. We're just going to deal with it like we normally would. Now this negative, you got to think strategically here. You're going to take this whole top to the negative second. You're going to take this whole denominator, I say top numerator, the bottom, the denominator, to the negative second. And what's going to happen is Chuck Norris will take this whole group out and knock them down, take this whole group up, uppercut them, and you're going to end up with 5y to the fourth over negative 7x to the 3 halves. This is to the second. This is to the positive second. You notice what we did was we just flipped it and then distributed this 2. So one big, bam, something very important. When you have a negative exponent plus a fraction, flip it. And don't take it out of context. Make sure it's the right context. The negative exponent has to be outside the fractions in parentheses, so make sure that you have that context correct there. But once we have that, flip that fraction and then distribute that 2 to both the numerator and the denominator. So we have 5 squared, y to the fourth squared, just Xerox it. Okay, 2 copies of y to the fourth, y to the fourth, y to the fourth, that's y to the eighth. This negative, let's say negative 1 times. So how many negatives are there? There are 2 negatives. So it's going to be negative 1 squared. That's 7 squared. X to the 3 halves, and I'm just going to put squared for the moment. Okay, so the thing that first comes to my eye is this negative 1 squared. 2 negatives are going to multiply to give you a positive, so this is going to be a positive. And really, we don't have to put the positive there, but we can just for instructional purposes. 5 squared, that's going to be 25, y to the eighth, over 7 squared is 49. Now we get to the interesting part here. X to the 3 halves squared. Well, there's 2 ways you can deal with this. First way, you could have x to the negative 3 halves. When in doubt, Xerox. Make 2 identical copies of it. And you're just less likely to make a careless mistake. So 3 halves times 3 halves. Remember, rack them up, just add them. So 3 halves plus 3 halves is 6 halves. 6 divided by 2 is 3. So we can just insert that down here, x to the third. And of course that's a lot easier than this looks. The other way you could deal with that is just to multiply this through. When you multiply that out, of course that makes it look like a negative. When you multiply that out, divide by the denominator, multiply by the numerator. So 2 divided by 2 is 1, times 3 is 3. So that's a little simpler if you can remember that trick. And then that's pretty much it. 25, y to the eighth, 49, x to the third. Let's double check. Do we have any negative exponents? No, both of these are positive exponents. Do we have any exponents of 0? No. Do we have any sort of nested parentheses where there's something we could simplify? No, we don't have any of that. 25 49ths. You could take the calculator to alpha y equals, pulls up the fraction menu, see if that's something that can be reduced. Of course, you could realize you could do a factor tree and say 25 is 5 times 5, 49 is 7 times 7. You notice nothing is going to cross out here and simplify, so you know this is completely simplified. This is it. This is all that we're going to do with this. So in each situation, just make sure that you've reduced it down as much as you can, and then you're done. That's it for today. Thank you very much. Have a great day.